Thank you all so much for coming out. It's the most quoted line in technology is that every company is now a technology company, right? Well, one of the implications of this is that engineering, efficiency, execution, how we do our jobs, this is no longer just something for a few nerds to obsess about in a corner. Like, engineering teams are the engines of modern businesses, right? The way we do our work, the speed that we do our work at, our ability to work on the right things and have fast feedback loops is literally what makes and breaks modern businesses. Which means that how well our teams perform, it's not the same thing as just saying, how good are we at engineering, right? Like, yes, you need to have data structures and algorithms and all that in your head, but it really pays to be in a high-performing team. And the way I define high-performing teams is teams that get to spend most of their time and energy solving interesting, novel problems that move the business materially forward. It's like above the value line, right? It's really easy as engineers to get sucked down below the value line where it's just a lot of toil and it's not contributing to forward motion. And every engineering team is going to have some toil, right? But really strong teams are ones that manage to consistently focus on things that matter. And one of the reasons this matters so much is that individuals don't own software. Teams own software. An individual who owns a code repo or a service, what do we call those? Single points of failure. Only teams can own services, right? That's what allows people to get sick, go on vacation. It's what distributes knowledge. It's what, So how do we build high-performing teams? Obviously, by hiring all of the ex-Netflix, Facebook, Google. No, of course not. Of course not. We build high-performing teams by hiring people who are good communicators, good collaborators, people who want to come to work and get a little bit better every week together. Because our ability to ship code swiftly, consistently, and safely depends less on what's up here is important, of course. It's necessary, but it's not sufficient. The speed at which we can ship software depends upon the socio-technical systems that we exist in and participate in. You can be the best engineer in the world. You can be Kent Beck. If you join a team that takes 2 months to ship a single line of software, how long is it going to take you to ship software? 2 months, right? We all participate in these systems, and they define the speed that we can deliver. Which is why I think technical leaders have one, and I don't just mean managers, right? This is everyone who's a senior engineer and up. Our number one job is paying attention to those feedback loops that are at the heart of every engineering org. Constructing, tightening, optimizing those feedback loops is what builds those great socio-technical systems. Which is why when I think about modern software development practices, I think about things like this. Engineers who, you write the code, you own it in production, practicing observability-driven development where you're instrumenting your code as you go, and then you deploy it, and you close that feedback loop by looking at it and going, is it doing what I expect it to do? Does anything else look weird? Testing in production, separating your deploys from releases, using feature flags, continuous deployment, managing the service level objectives. What do all these things have in common? They're all about fast feedback loops, right? They all interact with each other and amplify each other. And it's all about getting your code into production as fast as possible after you're writing it. Because at that moment when you've just merged your diff, you've got it all up here. You know more about your code than anyone ever will again in the future. You know what you built, why you built it, what you tried that worked, what you tried that didn't work, what the functions are called, what APIs it calls. You've got it all up here. How long does it last? I have a really bad memory, so like maybe a couple of hours and it starts to degrade. Certainly doesn't survive you paging in and out another project, right? But if you've got it all up here, you instrument your code, and then you look at it, you close that loop. That is such a powerful habit because, I'm pretty sure this slide is next. No, it's not. I think it's after this. But it's the key feedback loop to everything else. You can't get any faster than that, right? You can get a lot slower than that, but you can't get any faster than that. There it is. Because the cost of finding and fixing bugs goes up exponentially from the moment you write them. Right? You type a bug, you backspace, good for you. No one can find anything faster than that. You find it in your tests, excellent. Your next best shot of finding it is right after you've deployed it. Because if you don't find it then, who's going to find it? Probably not you. Probably a user. Maybe another engineer. And it's going to be weeks or months. It may even just fade into the background of, well, this is what normal looks like for everyone, right? The sooner you can find it, the more powerful it is. When it comes to software, speed is safety. It's like ice skating or riding a bicycle. When you slow down, which is very counterintuitive to us, right? As human beings, as embodied cognition, when we feel afraid or anxious, we freeze up. We want to slow down and get control over the situation, right? This is why we have deploy freezes before holidays. When do most outages happen? Right after deploy freezes. When we slow down, it does not make us safer. And our ability to do this safely, swiftly, consistently is grounded in the quality of our observability. What does that even mean these days? So many definitions of observability. This is a famous definition, probably the most famous. Observability has 3 pillars: metrics, logs, and traces. It was coined by vendors who, not so coincidentally, have 3 products to sell you: a metrics product, a logging product, and a tracing product. I'm not a fan of this one. But then they were like, oh, profiling, is that a pillar too? So many pillars. What is it actually? These days, when Christina and I first started talking about observability back in 2016, it was because we started Honeycomb in January of 2016, and monitoring was the big elephant in the room, right? And we were trying to figure out how to talk about what we were building. And the ways, we had to write a database from scratch, and I maintain that the hardest part of building Honeycomb is trying to figure out how to talk about it. Product marketing is no joke, y'all. It is hard. But in July of that year, I remember Googling observability, and it took me to the Wikipedia page. And turns out observability comes from control theory. Observability is the mathematical dual of controllability, and it means how can you understand the internal system state just by observing its outputs. And I had one of those moments, oh my God, this is what we're trying to do. These days, I think of observability as a property of complex systems, just like resilience, just like performance. I like this definition because it places the emphasis not on the tools, not on the vendors, but on the systems themselves. The problem with this definition is that it really it flattens it, right? If everything is observability, then what does observability even mean? And it flattens over that original itch that we were trying to scratch and reaching for a new term, which is that sort of palpable difference in sort of generational tools, which is why these days we've started thinking about it in these terms. When it comes to semantic versioning, what are major version bumps for? They're for backwards breaking incompatible changes. And this is how I think of it these days. 1.0 is the 3 pillars world. You've got your metrics, logs, and traces. Actually, you've probably got way more than that. You've probably also got a RUM tool, and an APM tool, and a profiling tool, and analytics tool, and your structured logs, and your unstructured logs. And 2.0 has a single source of truth. Arbitrarily wide, structured log events that have trace IDs and span IDs so that you can visualize them over time as a trace. They're wide and rich, so you can slice and dice. You can derive metrics from them. You can derive SLOs from them. You can derive all the other data types from them. But because you've preserved that context, you can go back and forth. It's not a one-way trip, right? If you derive metrics from your wide logs, you can't get logs back from the metrics because you discarded all that context, right? So this is a super high-level overview. I'm not really going to linger here because we're going to go into each one of these in a bit more detail. Starting with this. The most common objection I hear is this. We're not ready for Observability 2.0. We are still really struggling with 1.0. Someday we'll get there. We'll figure this out, and we'll be ready for 2.0, which is such a funny objection to me because you don't hear people going, God, we have not yet figured out MySQL 4.1. We're going to get there, though. We're going to get to MySQL 8 someday. It turns out the way people are doing it now is the hard way. Oh my God, it is so hard trying to use all these different data types, trying to educate your teams about when to use metrics, when to use logs, how to compose a good metric, where does your cardinality go? And then the cardinality can change out from under you, and your bill goes up, and everybody's just like, what? It's really, really, really hard. The way people are doing it now is the hard way. It can be a lot easier. The world's getting a lot more complicated. This is not news to anyone. And our tools were designed for much more predictable worlds. There are only really 3 data types under the hood. There's the metric, the unstructured log, or strings, and there's structured logs. You know, in the early days, Honeycomb really avoided, we were like, we don't do logs, we do events, which was one of the decisions I regret the most. The reason that we did not talk about logs was because back then, 8, 9 years ago, all of the connotations, when you said logs, people thought, unstructured data, strings, you know, being emitted just sort of willy-nilly throughout the life of a request, just boop, 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 lots a little bit. And all of those assumptions are the opposite of what good logs look like. And I feel like the world has come a long way since 2016 when it comes to the assumptions that come to mind when people talk about logs. Nevertheless, anything can be a log, right? Any data you have can be a log. A metric, though, is just a number. With metrics, you can do math. With strings, you can search them. Is that really all I put there? When people say the word metrics, they can mean one of 2 things. They can mean just the generic synonym for telemetry, right? My metrics are bad, my metrics are good, my blah, blah, blah. And they can mean like big M metric. The metric is a data type that is just a number with some tags appended to it. And it's stored in a time series database. And what's important to know about that is it stores no relational information whatsoever. So if you've got a metric that's shaped like this, and another metric that's shaped like that, you might guess that they are describing the same events, but you can never validate that guess. It's only a guess, because there's no connective tissue between them. That's why it gets so incredibly costly when you try to store tags with cardinality, because for every single additional detail that you want to store, you have to store the metric again. So data structures, like you said, Observability 1.0 is your pillars world. And in 2.0, you store these arbitrarily wide structured data blobs. One of the important details about that is that in 1.0, you do all your aggregation and decisions about data types at write time. And one of the beautiful things about 2.0 is you postpone those decisions. Those are all going to be made at read time, which means you can make different decisions. You can slice and dice. You can zoom in. You can zoom out, because you always have that single source of truth. This is one of the most fascinating things about what's going on throughout the industry, whether people are using this language or not, is that historically, observability in the 1.0 days was all about how you operated your code, right? It was very much seen as an ops domain. You know, software engineers, I identify as an ops engineer, right? And for the longest time, it's like software engineers would write the code and be like, well, go give it to the ops team to add some metrics, you know? This is insane. No way to write software. And then the 2.0 world, well, in 1.0, like, because it was very much an ops concern, you know, it's still, a lot of the discourse revolves around crashes and bugs and errors and MTTR and MTTD and all these operational concerns. And 2.0 encompasses those things, but I really feel like Observability 2.0 is much more about how you develop your software, right? Which means it's not just about bugs and errors and outages either. It's about making sure that the value you're creating is what you meant to create. It's about having those really tight feedback loops of, is it doing what I expect? Does anything look weird? It's about understanding how your users are interacting with the code that you wrote, right? It's about understanding the interaction of your software, your production systems, your users, the product. How are your user patterns changing? What are your users really leaning into? What are they loving? What are these unexpected little dopamine hits that, understanding your software is so much fuller of a picture than just, is it up or down? And partly because of that, as a result of the data structures that were captured in 1.0, dashboards were static. Now, one of the other things that I regret a bit as a life choice was all the time I spent being angry about dashboards. To be clear, dashboards are a positive force for good in the world, mostly. But they should be dynamic. Static dashboards are really only good for execs, right? If you can't ask a question, if you can't dive deeper, if you can't explore your data, it's not really a development tool. It's a reporting tool. And we need development tools for understanding our software, right? So dynamic dashboards are very good. Paging and alerting. So, I'm old enough that I remember when it was seen as a great victory that you didn't need to sit around looking at dashboards all day. The system would let you know. It would page you when there was something you needed to look at. This was because we were reacting to the days when there were literal NOCs, network operation centers, right, and data centers, people who got paid to sit there staring at walls of dashboards all day long. It was a bad job. Bad way to do it. Absolutely, it's better to have software let you know when you need to look at it. But now, I feel like it's actually kind of swinging in the other direction because we're expecting engineers to be on call for their code and support their code in production, right? And because of that, or also because of the increasing complexity of our systems, the bar for what we page people on should be quite high, right? You should be paging your engineers, waking them up, only if your customers are in pain. Customers are in pain, engineers are in pain. These things go together, right? But there are lots of things that can happen to your software that don't rise to this level. And so engineers need to have habits, they need to have a muscle memory of looking at their code, of interacting with it in production, not feeling like their job is done when they hit merge, right? You don't merge your code and walk out the door. You merge your code, you look at your instrumentation, you make sure it's doing what you want it to and expect it to, and then you leave, right? Sometimes these are bugs that you might find. Sometimes they're just behaviors that you need to understand. But it's really important that you not just look at your code when you've gotten paged about it or when something is down or when there's a bug, because you need to know what good feels like. You need to know what normal feels like. In my opinion, that's basically the definition of a senior engineer, someone whose gut you can trust. And the way you train your gut is by consistently interacting with your code in production. How you interact with production. Well, we just talked about some of this. But one of the artifacts of storing your data in pillars is that you kind of need to know what to look for before you can find it. And one of the things about Observability 2.0 is you should be able to reliably find novel issues without knowing they're there to look for. How you debug. In a 1.0 world, you've got got your metrics, dashboards, you've got your logs, you've got your traces, you've got your profiling, you've got your RUM, you've got your APM. And what connects them? You do. You sit in the middle of all these tools, and you probably have some familiar dashboards, you have some bookmarks, but you spend a lot of time just going, well, that looks like that, or I'm going to copy paste this ID from my logs tool over to my tracing tool and hope that it got captured, right? You're sitting in the middle of all of these things, and because the connective tissue does not exist in the data, it exists in your head, it means that you rely on a lot of guessing and a lot of intuition and a lot of exposure to, well, this has happened before, therefore I know to recognize it. And as a result of that, the best debuggers are always the people who have been there the longest. Don't get me wrong, I love being that guy. I have made a career out of being, the first infrastructure engineer to join a bunch of software engineers, and being the debugger of last resort, and being able to go, I see, I know it doesn't say it anywhere up there, but I'm telling you, the problem is Cassandra. And everybody's like, what? How did you know? And you're just like, I am kind of a god, you're right. It feels amazing, but it's not good. It doesn't really scale. It doesn't scale, and you can't go on vacation, and also it's just kind of depressing to know that you join a team and you could never catch up, right? You could never be the best. And I always used to think that this was just baked into software and complex systems. This is just the way it is, but it's not. I've worked now at a couple places, at Facebook, Parse, Honeycomb, where the best debuggers are the people who are the most curious, the people who have a habit, have that sort of muscle memory of looking at their code. And in fact, it's a little funny. So I was engineering manager at Facebook, and I had built, the original set of Nagios and Ganglia and Graphite and all of these dashboards and stuff, and I knew my way around them just, like the back of my hand. And so we were having all these reliability issues, and some of the young whippersnappers were like, why don't we try some of these Facebook tools? And I'm just like, ugh, all data tools are alike. And the most junior person on our team started feeding some of our data sets into this Facebook tool called Scuba, and started finding problems before I could figure them out. It was humiliating. And that's when I was like, well, shit, I guess I should get on board. So that's a great feeling, right? When the junior people on the team can debug things faster than you can, a lot of times people will often come up and be like, maybe 1.0, maybe 2.0 is easier than 1.0, but there's always friction involved in a change, right? If you're asking someone to learn something new, it can't just be 20% better or 50% better. I think when it comes to dev tools, if you're asking somebody to make a major change, it has to be either an order of magnitude cheaper or an order of magnitude better than what they've got to be worth that. And so how do you motivate people to do that? You give them those dopamine hits of finding a thing before the principal engineer could. That is some hot shit. That is addictive. The cost implications. I've written a lot about this in recent months, so I'm not going to spend a whole lot of time here. But in the 1.0 world, no matter how good the tools are, you've got a multiplier, right? For every tool that you're paying for, every request that enters your system, you pay to store it again and again and again and again and again and again. And I think that, in the zero interest rate phenomenon era, money was free, and we kind of were just like, well, what's the worst that can happen? And then we all went broke, and that was the worst that could happen. But it's actually worse than that. It's worse than the multiplier effect, because the most important thing for helping you find problems in complex systems is the cardinality of your data, the detail of your data, being able to see things with specificity, right? In metrics, a common cost-cutting thing that people will do is to bucket HTTP status codes. There's 63 status codes, and typically they'll bucket them into 1xx, 2xx, 3xx, 4xx, 5xx, right? Cardinality is expensive. But it's actually really meaningful whether something's a 502 or a 504. You know, I don't know how many times I have tracked down some weird-ass error just because it had a unique status code or a weird browser string or something with detail, right? Detail is what makes systems comprehensible. And anything that's backed by metrics is going to be this constant dance. I know entire observability engineering teams, good ones, that are spending an outright majority of their time just managing that trade-off between cost and cardinality. We were in New York City 2 weeks ago, and that Matt Sanabria from Cockroach Labs was telling me right before my talk about going to bed the night before with a cardinality of 75,000 and waking up with a cardinality of 3.1 million, and oopsie-daisy, that'll blow out your bill for the year. And ironically, that's the kind of detail that is the most powerful and precious to you as an engineer trying to understand your systems. So it's painful. I will never try and claim to anyone that good observability is cheap, though. It's not. You've got your cloud hosting bill. Number 2 is probably going to be your observability bill. 10 to 15% of your cloud bill, I think, is what good disciplined teams can get it down to. Obviously, I'm a vendor, so take that with as many grains of salt as you want. But I did say that back at Facebook, back when I was like, I hate telemetry. This is always going to be someone else's job. So, yeah, how did that work out? Great question. I'll let you know. So, in my opinion, cost is a thing, but what's more important is that your cost be predictable and aligned with value. If your bill is going up and the value that you're getting out is not going up, that's a huge problem. And that's one that I feel like the Observability 2.0 model is poised to solve. Ultimately, it kind of comes back to the original definition from control theory. Observability for software engineers just means, can we understand our software and our systems? Can we understand the inner state of our systems just by observing its outputs? And can we do this without shipping new code to handle the circumstances that we're trying to understand? Because if you have to understand, if you have to know it's there and instrument it before you can understand it, then you're stuck in a costly catch-22. We build better systems by building software this way. I don't think that's arguable, but I also feel like we build better engineers by building systems this way. And I feel like, you know, especially with the advent of AI, like my take on AI is that I honestly think of AI as almost just kind of like another database. It's like a database type, but like it applies all of the power of automation and computation to, you know, in the past we could do that with structured data and numbers, and I feel like AI is applying computation and to unstructured data and language. I don't feel like I feel like what it is it's accelerating a lot of things. You know, I'm old enough that when I got to Silicon Valley, it was still, you know, people were like, bro down, crush code, sleep under your desk, you know, let's just like work 16-hour days, and that's how we build great, lots of money. And there are some things that you can do that with. You can brute force some things, but fewer and fewer of them are jobs, right? The things that are being automatable are being automated out of existence. The things that remain for us to do are things that you can't just brute force through. They take creativity. They take people who are well rested, who are well fed, who are emotionally engaged in their jobs, who care about what they're trying to do and build. We can't hold a model of these systems in our head, and teams that try to guess the answers will lose. Our systems are increasingly emergent and unpredictable. We can't run them using runbooks and canned playbooks. It really takes our full creative engagement. I feel like Observability 2.0 is here to help advance the craft of software engineering, which ultimately is about ushering change into the world safely, faster, and more safely, more predictably, reliably. I continue to hold that even if Honeycomb goes out of business 5, 10 years from now, this is how people are going to be understanding their software, because it's becoming increasingly impossible to understand it any other way. I think that is inevitable. Our success as a business is not. But in conclusion, observability is not what we're here to do. There's something else that you're here to do. It's your business. And observability is one of your most powerful tools in making your dreams come true. So I always close with this. Are we too busy to improve? Yes, no, hopefully not. Thanks.